So if you're doing landrace gardening, saving seeds from genetically diverse populations to reuse in your garden, how much do you need to know about genetics? How much do you need to know about breeding? And there's kind of two answers to that. One is not that much, actually, because these things take care of themselves. You are not, keeping very many records, and you can get away with a pretty general sense of what does and doesn't cross with each other. However, if you're interested in knowing more about genetics, then there's a lot that's there to be learned if you'd like to, but it's not really necessary. And another interesting thing is that we sort of look at genetics in a more sort of abstract way, with a certain level of abstraction. And by that, let me give you an example. The tallness of a plant, the tallness of corn, for example. There is not a single gene in corn that's responsible for that. You will never find the one thing that will make plants tall. It is a symphony of all sorts of genetic words stacked on top of each other, right? You could think of it as, sadness is not a thing that you can just sort of pour into someone, but that you can, tell them a story with words, and it makes them sad. So we're looking at genetics in the abstract here. So with a certain level of abstraction, we can then ask questions like, theoretically, is there a genetic that can outcompete the weeds in my garden? Theoretically, yes, there is. We can continue to select for, what would you even call this trait? We have these traits, some of which are abstract and some of which are, genetically isolated, right? You can, in fact, find the genetic word in the DNA, right? The genetic sequence is what I mean by word. So, but you can ask these sorts of questions, in the abstract. In the abstract, there is a certain breed of everything that I grow in my garden that will, through my selection, whatever my criteria are, could really be amazing, right? So tallness, is an abstract trait, not a single gene for tallness, right? Flavor of your vegetables, that's not going to be a single gene. That's sort of again, a concert, a symphony between the soil and the genetics. But I would say if you want to know some things about, conventional scientific breeding that are going to matter and some things that don't, this is where I would start. Cytoplasmic male sterility. That's CMS for short. Joseph Lofthouse talks about it in his book. I'm talking about you. I'm talking to you about it as well. And what this is male sterility, which they use to make F1 hybrids. Okay, and so this is going to happen on plants that have kind of small flowers. And let me give you an example. So this does not mean any of the cucurbits, right? So that's going to be ones that have big flowers, right, and that you can get, hundreds of, right, a guaranteed F1 cross, right? You can get hundreds of seeds off of one basic, pluck, one shot of pollen, if you're really trying to isolate. And so the way that they do that, okay, so here's an example. This is a brassica. Brassicas are doing terribly, right, flowering. They try to flower right now, and it's not happening. You see some seed pods are developing, so maybe it's happening a little bit, but as you see, the further you go up, right, and this is also kind of chronological order here from top to bottom, it happens less and less. But what I'm looking at here is these small flowers. And so when you make an F1 hybrid on a brassica, you are not going around pollinating every single flower, right? That would be really tricky to do. In addition, it's going to be very difficult to keep the plant from pollinating itself, okay? What they do when they are, getting specific with something like a moschata, say you're trying to make a moschata F1, right? They're going to find a female flower, and then they're gonna close off. They're gonna close off the first. They're gonna tape it shut or something, right? So that they know that nothing has touched this pollen-wise, right? And then they go and get the pollen they want and open up the flower and pollinate it by hand. But you simply can't do that with a brassica because it's got male and female flowers. It's going to pollinate itself, which you don't want. That immediately makes it not an F1. And you're trying to sell people something that has got guaranteed hybrid vigor. So they use male sterile plants. They breed in genetics where one of the two inbred lines is male sterile, so then they can guarantee that the only pollen that is pollinating the female plants is going to be from the specific pollen donor. So that's a trick they use, but you can see why you don't want that in a landrace situation, because you want as much male and female contribution as possible. And as Joseph Lofthouse has said, either in his book or online, I don't remember where, but why would you purposefully put in deficient plants? And so this is a technique used not just on brassicas, but anything with lots of small flowers. So that's going to be also things like carrots, right? So carrots use CMS to make hybrids. So you don't want to put just any old carrot in your rig, in your sort of seed system, if you can get away with it. So that means starting with inbred lines, old school, I guess what we would call open pollinated carrots. And so those are two big ones. I'm trying to think of, there are other ones as well. Lettuce, here's an example of lettuce that's flowering. And again, you can see there's lots of flowers. They pollinate themselves rather easily. So if you are lettuce, I don't know how much lettuce is used with hybrids, but that would be another example of a plant where you don't want F1s. Sunflowers. Yeah, that's I believe another one you want to avoid F1s of. These are all in Joseph's book. You can check it out there. Okay, so I would say that's the main. I would say that's rule number one, at least for me. If you get it in, if you get a bunch of carrots that have CMS, they're still going to be able to take pollen. So as long as you've got a lot of male donors, as long as you've got enough stuff that's not infected with CMS, then it's not gonna take over, right? Because there always needs to be male, and right, if it's coming from the male, that means that it does not have CMS genetics. So I don't know if it's dominant or recessive. But the work has been done on this, and it's just best to avoid. It's really not that tricky to do, I don't think. Just avoid F1s. You just have to consider, you know, how does an F1 of this plant get made by a commercial company, basically. And if there's no way to do it without male sterility, then those are the ones you want to avoid. Okay, so another big one is of the cucurbits, what crosses with what? And as far as I understand it, it just goes pretty much straight across the board. So C. maxima is not going to cross with C. moschata normally. If it does, you get Tetsukabuto. And what a blessing that is. So you get some sort of, you know, interspecific hybrid. Would you even know it if you weren't planning on it? I don't know. But so yeah, they don't typically cross, and that's true of all the moschatas, as far as I understand it. So Peppo is not going to cross with moschata or maxima. That's how I understand it. So you do not have to. You're not going to get sort of mutant things. Although, if you do, if you can breed male sterility back into them, then go for it. Tomatoes you can use F1s on, because a tomato plant, think of the logistics of making a tomato F1. How many seeds do you get from one injection of pollen onto a tomato flower? 100, usually about 100 to 200, I think, per tomato. So that's one where, yes, right, it's going to be a good idea to just do it by hand. That's economically feasible. That's basically what it is. So yeah, as far as logistics of saving seeds, you can be pretty sloppy and still get usable seed. Of course, fresh and dry. Take them fresh, get them dried down quickly, store them in an airtight jar or airtight container. Those are the basic rules there, I would say, if you want your stuff to last really long. But I'm sometimes really sloppy about stuff, and will just let, a cucurbit of some sort rot, and then just come back to it later. Be like, well, the seeds are still there, and return to those. And those, they're viable seeds. If you do even just a little bit of seed saving, I think you will see how easy it is to get volunteers. Let me show you an example of this. I'm going to have to go out of my garden, because where I do some of my seed saving is just in this other shed here. This is the shed close to the house. You will have volunteers everywhere if you do any kind of seed saving. This is my promise to you. And let me show you an example. This is my lawn. I'm sort of mentally preparing a video about what I think about lawns. Stay tuned for that one. Okay, so there are 3 watermelons just popping up out of the grass here. And then some other, cucurbit right here. Look at that. I mean, so, yeah, and this is just from, this is where I dry down seeds and process things, stuff like that. And, so right there are a few things that are kind of hard to get growing, right? Watermelon, watermelon's not an easy one. And there we are. So, yeah, you will accidentally get volunteers if you're doing seed saving. When you clean your seed, when you winnow it, things like that, I would, highly suggest just go somewhere out in your garden when you do that. That's a good way of promoting volunteerism in your garden. And you know, stuff just pops up in the strangest places, even without using seed balls. I know that, you know, and I'm not a master of the seed ball. I've done seed balls a few times, and I think that the payoff is almost good enough, right, to abandon the idea of seed balls. If you just wisely throw your seed on the ground. This is my hypothesis. But yeah, if you're really having trouble, use seed balls. That's going to vastly increase your chances. But I don't actually have a lot of experience using it. Again, I think just throwing seed on the ground. All this okra was planted that way. All that lettuce was planted that way. These were planted that way. These were not dug in. I did top them off with a handful of soil and came back to water them a few times. But you can see that cool stuff can happen. That kale wasn't dug in. That was just dropped on the ground. Here's a carrot. Yeah, carrots are actually doing really well. Granted, I mean, I probably planted somewhere around, I don't know how many, you know, there's tons of seeds on it, you know, carrot flower. And so yeah, maybe 10,000 or something like that. And it's good. It's great. I see them all over the place, and they just kind of pop up from out of the grass somehow. So carrot is going well. I guess, you know, it takes a certain amount of seed for sure, but you get a lot of seeds with carrot. And as far as when they're going to germinate, you know, if you get a long time to kind of think about it. Spring, of course, would probably be a best time to plant carrots. But I've seen them come up. There's lots of real small ones, even in sort of strange places in the garden right now. So I would say things are looking better with carrots. I pulled one up the other day. I was worried that it was already tainted with QLA, Queen Anne's lace, but I pulled one up and ate it, and it was great. Tasted like a real carrot, a real domestic carrot. So, yeah, carrot. "Oh me of little faith" is one that I think you really can actually get a good thing going with in Landrace, and just by surface sown. What should I call my technique? Surface sown Landrace, no till. And yeah, I see that as a viable one for sure. It's actually going pretty well. I'm seeing them all over the place, and they are confirmed to be edible carrots. Yeah, as far as genetics, I would say that's pretty much it. No, I mean, there's a lot to actually learn if you want to, but at the end of the day, if you follow a few pretty simple principles, which is, right, that, you know, children resemble their parents, and humans have had understood this for a very long time, right, and that, you know, really beautiful and intelligent cultures have developed which they understood how to take these wild plants and to make them their own and to manipulate them. So the level of genetic understanding that they had was really vast, right? With probably, you know, I'm sure without knowing about anything called DNA, right, in any formal sense, not knowing anything about chemistry or the science that we have, but that they had their own science. Everybody had sort of a folk version of science that they carried around and shared via word of mouth. And that's really beautiful, and I hope that I can kind of try to do that here to give you something that you can take, and that it will help you thrive in the world, to have peace and nutrition and good times with your friends and family. Because that's, you know, what the hell else are we on this planet to do, right? Thanks for joining me today.